session today. Hey, Benny, how you doing?
Hey, doing good. Can you hear me?
Yep, all's good.
Okay, perfect. So thanks for the introduction, Jake. And again, everyone, if you were on yesterday, we're just going to kind of continue where we picked up yesterday. Yesterday was a beginner session, and today we'll be looking a little bit deeper into some of Cayenne's features. And I also want to reiterate that this is totally live. I'm adding sensors and reading data in real time. If anything goes wrong, we're all going to blame Jake. I just want to agree on that, if you will. So we are My Devices. We believe that the Internet of Things starts here. And our mission is to simplify the creation of IoT and IoT projects. And we do this through Cayenne, the world's first drag-and-drop IoT project builder that empowers all of you to quickly create IoT projects. The general agenda to today, I'll do a very, very brief introduction to Cayenne for those of us who weren't on yesterday. We're then just going to touch on playing around with the relays with the Raspberry Pi. And the reason why I wanted to go over this is because a lot of the projects that are being submitted in the community involve relays in the Raspberry Pi. So I figure, well, why not just do a very brief overview of that? We'll then get into custom widgets with Arduino. With custom widgets, you can add any sensor that you want to Cayenne. So this is really powerful. And you also get to learn a little bit about some of the basics of coding with custom widgets as well. We'll then jump into the Cayenne community, talk about some upcoming features, and go into some Q&A. So with that, I'll go to my video feed. And I did just want to briefly touch on Cayenne's features. If you're new and you haven't used Cayenne before, we offer a customizable dashboard, which I'll show you in just a sec, remote monitoring and control. And we do have iOS apps and Android apps as well that come native with the platform. So I'm doing everything from the web dashboard right now, but actually I might as well do this today. Why not? I can actually log into my account on my phone and then play with what I've created just now. So we'll do that as well. We have alerts, sending yourself a text message and email, triggers, make device A do something if device B reaches a certain threshold or whatever it may be. Scheduling, which is like time-based triggers, visualization, and actually data history and data storage as well. And yeah, let's get started. And it looks like, okay, good. So yesterday what we did is we got an Arduino online. I'll show what we did. I just plugged them back in here. We got an Arduino Leonardo online with a potentiometer, which I like to call a potato meter. Kind of funny, I know, and an LED. So let's just make sure those are connected. You can see I just turned the LED on through my dashboard. And if I turn the potentiometer or the potato meter, you can see that the data is changing in real time on my gauge here. So we know that's online and that's connected. What we also did is we played with the Raspberry Pi. I'll go to that dashboard now. And we added a BMP 180 temperature sensor and we got an LED going. So here's my Raspberry Pi dashboard. I'll turn on the blue LED. You can see it did turn on. And I'll also just make sure the temperature is correctly reading data. So I'll put my finger on it and look at my dashboard to make sure that the temperature is increasing. So it's at 71, 71.7. Okay. It seems to be reading in real time. So let's get right into it. With the Raspberry Pi, it has this idea of the GPIO pins on the Raspberry Pi, and each pin has a specific, I'm pointing to them right now with my finger, each pin has a specific function. Now, I brought this up yesterday as well. I use this all the time just because it's very helpful to reference. So let's see how I make it. We'll keep it here. So each of these specific pins has a function. Now, the BMP 180 sensor is an I2C sensor, which means it needs to use specific pins on the Raspberry Pi. So you can see that there is, you'll see if you have an I2C sensor that has SDA, SCL, and those are the I2C pins. And you can see on your card here that you can reference, those those pins on the sensor need to be connected to the correct pins on the Raspberry Pi. Now you can add a total of, I think it's like 122 or 129 I2C sensors on these two pins here. So it's not limited to just one. There's SPI pins, which are these ones in purple here. And those are a specific type of sensor that we're actually not going to cover today, but you might experience it when you're making something. And then there's these very general pins, and they're in green. So they're these ones here. And ultimately, this is what we're going to use to turn on and off a relay on our Raspberry Pi. So I guess real quickly, what does that mean, turning on and off a relay, or how can I create some cool project with that? Well, to quickly illustrate that, I'm just going to hop into the community real fast and go to our projects made with Cayenne section, because that's what our community is using, is relays and different things to turn on their whatever device is connected through their Pi. So let's do this project here. You can see he's actually using an Arduino, which is totally fine, but this is the relay here, and that it basically sends a high or low signal and turns off some device using the specific GPIO pin that we went over on the Raspberry Pi. So that's an example of a project that's using the GPIO pin to turn on and off a relay. Now, I am actually not supposed to be working with relays here at the offices because it can be dangerous, so I am obligated to tell you, if you're going to work with relays, there's tons of tutorials on the web for them, but I actually found a pretty cool device, which I would totally recommend using if you're just getting into things, and it's this device right here. Take this off here. So this is a relay, but it's safe. You're not going to shock yourself. You're not going to accidentally touch a wire and get electrocuted. And it's really cool because you can just attach these two basic breadboard wires directly into the relay itself, and that's what actually turns on or off the device that you're trying to connect. So that's what I wanted to showcase today, because it's a really safe, easy way to get started before you actually go with playing with cutting wires from an electrical cable and plugging it into a relay and connecting it to the Pi. Because it truly is, it can be a safety hazard. So that's why I can't do it here at the offices, but at my house I can do whatever I want, which is nice. So hopefully you guys can also do that.
Hey, Benny,
so,
before we get started, can I ask a couple of questions from the audience?
Yeah.
Before you blow things up. I was wondering, Ray had a great idea of maybe including that pins map that you've been referring to and just put it on the Cayenne workspace. Have you ever thought of that?
Yes, and actually that is, that's a good point. And I actually usually do this, but typically when I do classes, I hand out these cards. I have a ton of those GPIO cards. So on the Cayenne website, on your dashboard, if you click on GPIO, which I just did, it has the same mapping as well. It doesn't look exactly as that example that I showed, but you can see here that we've highlighted in blue the I2C pins. There's the SPI pins here. One neat thing, if you have a one-wire device, and I don't have one around my desk on me, I usually do, I have things everywhere. But these one-wire devices, like there's a sensor called a DS18D20, if you connect the data pin through GPIO 4, which is on our dashboard right here, then Cayenne will automatically add a widget, and you don't have to actually do anything to add that to your dashboard. So that's one pretty cool feature of Cayenne. If you connect a one-wire device to GPIO pin 4, it will automatically populate your dashboard with that widget. So great question. I should have actually led with this, and we'll actually touch on this right now as well as we get into things. Is there another question?
Yeah, just one more, because we're talking about drivers and stuff. He was wondering, gentleman Mike was wondering, is there a tutorial on making a driver for a non-supported device?
Yes. So we use actually an open source abstraction layer within the Cayenne install. And I'm going to go to the website right now. For a lot of the hardcore Pi guys, a lot of them I've talked to have actually heard of WebIO-Pi. This is an open source project that was created by a guy named Eric Patak, who's French. and he lives in. I saw in the chat there was someone from Paris. So we actually do have offices in Paris, and he goes there in Paris, and he lives in Lille, L-I-L-L-E, where Eric lives. But anyways, so he created WebIOPie, and he now is on the Cayenne team. So we use the drivers that were within WebIOPie, within the Cayenne install. There is a API doc that you can reference to bring on your own driver, add it to the WebIOPie config file within the Raspberry Pi, and then that would be able to populate on the dashboard. Now, it's a very technical document. It's very dry. It's a long page of just technical information, and I've given it to some people, but no one's really created anything from it because it is hard to read. Honestly, it is. And what we are doing is we are creating a much easier process for you to write your own drivers, bring them into Cayenne, and then share those drivers with the community. So if you create a driver for a specific sensor that you want to get on, let's say it's like a DHT11, which actually we'll get into with the Arduino in a sec. If you create a driver for the DHT11 for the Raspberry Pi, and it works, you'll be able to share that driver with the community at large, and that will be really helpful. That's something we're working on, though, and that is our CEO in the background right there. But that's something we're working on, and we can't wait to give it to you guys. But for Arduino, you can add any sensor. You don't need the driver integration like the Pi. Is that it, Jake?
Yes, that's it.
Okay.
I was just wondering who that guy is running in slow motion. Was that slow motion, or do we have tape delay?
No, that was slow motion. That was Kevin. That was Kevin Brummer, CEO, ladies and gentlemen. So back to this neat little device. It's made by digitalloggers.com. I can post a link somewhere after. But what's really neat, I'm going to switch to the Raspberry Pi feed here, is get the Arduino out of the way, all I've done is I've connected 2 wires, one to the ground pin right here, and then the other to GPIO pin 26. And that's connected on the Pi. It's the orange and yellow wires right now. So what I can do now on this device is just connect the same pins right into that green area right there. And so there's a ground and a power section. So all I do is connect them right here, and it's in the pin of this relay. And the relay is connected to an external power source. It's connected to just a power outlet right here. So that's what's actually generating the correct voltage to turn on this little lamp here. So I'll add this lamp. This is just a very simple plug-in, and I can plug a light just to kind of prototype a little bit. So I'll plug it in here. And actually, it might be better to switch to this view while we're doing this. So I'll plug it in here, and now what I can do is I can switch on my GPIO view on Cayenne. I can switch it to an output, and what that's going to do is it's going to allow me to send a signal from my GPIO on the Pi through the wires and directly into this relay. So that's why I'm turning it to an output. Now, it's sending a low signal, but if I send a high signal, you can see that it now turns on this light. And I can change it from a high signal back to a low signal and turn on and off this light. Now, I can attach anything to the end of a relay, and this goes for you guys as well when you actually start playing around with your own relays. Now, I've done a light just for the purposes of demonstration here, but I could just as easily attach a lamp, a fan as well. So anything that has a plug, I can now, let me turn this to the off position. I can now attach to my relay, and now if I turn it back on, you should see, as my fan is on, you can see the fan's now going. So I can now build these really cool projects remotely and turn things on and off directly from the Raspberry Pi. And furthermore, I'm going to switch back to the lamp just because it's a little bit chilly in here and I don't want to get blown over. Everything as well that I'm doing right now is also available through our app. So I'll show it here. We have the GPIO view on the app as well. So I can go and scroll through, and just like I was doing on the web dashboard, I can find my my pin 26, which is right here, and I can push it, and now that turns on the light. So I can do the same thing from the web dashboard as well as from the app. So that's playing directly with the GPIO interface with the relay. Now, the next step here, once I know that this light is working, would be to add it through as a widget that I can actually interact with on the dashboard, and that's a very simple process. So I can go to actuators, I can click on light. We have a light switch widget, but I can also do a generic digital output. That's what I'll do, and I'll do relay light, select my device as the Pi, choose the connectivity. We're using the GPIO on the Pi. The channel, if you remember, it was channel 26. So I'll select that channel. Obviously, we'll be using a button, and I can select the icon. Since it's the light, I'll choose the light. We'll add the actuator to the dashboard. And you can see that I can now control my light. Oops.
Hey, while you're doing that, what is the typical latency, of that?
So that's
switch?
That's a good question, and it really depends on your connection, both on the Pi. Yeah, mostly on the Pi. What I have noticed is Pis that are on Wi-Fi might have a 2 or 3 second delay, but we are working on improving that delay through Wi-Fi. But if your Pi is hardwired, then you can see it's not even a second delay when I turn it on and off on the dashboard here.
Yeah, and Ray was wondering, can it be improved or made speedier with a local server?
Yes, it can. That is a endeavor that is on our roadmap. It's a little bit behind other features. So a big request in our community has been the ability to localize Cayenne. So if you lose access to internet, you can still run it. It doesn't matter. And we do want to meet that need, but we just haven't had the time to actually go and provide a local instance of Cayenne. But our scheduling feature does run locally on the Pi. And another, going off that, something else to note is with the app. So when you're using the web dashboard, and you're turning on the light, it basically goes from the cloud all the way to the Pi. So that's why there's potentially that 2 or 3 second latency delay. But with the app, if you're on the same Wi-Fi network or the same network as your Pi, then it doesn't need to go to the cloud. It just travels directly, basically from your phone to your light. So that enables you to really get some very, very quick turning on and turning off if you're doing it directly from your app. Like, for instance, in your house or something like that. So you can see that it's really quick because I'm on the same network as my Pi here, my phone is. So I can just quickly tap and it just turns on and off. The web dashboard, I wouldn't be able to do that because it goes to the cloud, sends a command, then waits for the response, the confirmation response. So then it's waiting for something to go back to the cloud, and then it reflects it in the dashboard. So that's why it's a little bit slower on the web dashboard as compared to the app here. Yeah. And was there any other questions, Jake? I was going to get into a trigger.
Nope, that's it. So far, so
good. Okay. So very quickly now, so you've created this relay, whatever is connected to it. It might be a fan, a light. You can connect virtually anything to a relay with your Raspberry Pi, and it's very easily now. It's very easy to create triggers. I did a trigger yesterday. I'm going to do a trigger again today, just for those who are new. If you've seen it, please bear with us. So this is our triggers section, if you will. This trigger will be turn on red light if heat goes up. So I'll drag my device to the if side. I think this is making it. Drag my device. The if side, select something that's connected to that Pi, which is going to be my temperature. We'll go if it goes above 74 degrees. And actually, rather than turn on the light, no, we won't set up a notification. And drag your Raspberry Pi over again. We'll turn on that light, that relay light that we just added. Save the trigger. And make sure it's on. It's on. Go back to our Pi. I'm going to switch the video feed. And if we grab that temperature sensor here, you can see it's reading 72.5. If I put my finger on it, which I'm doing right now, and the light just turned on, it's kind of hard to see, I guess, but it did just turn on. So that, and the triggers do work very fast as well. So that was what I wanted to cover for the Raspberry Pi, is using a relay for your project. That's really what's going to take your project to the next level, because there's only so many things you can do with just turning on or off an LED or something like that, right? You really want to start using something that has a real-world application, such as this light here. I'm going to move now to Arduino. Were there any questions for the Raspberry Pi, Jake? Jake, are you there?
Oh, sorry, I was talking in my mute. Saying we're all caught up.
Okay.
We're caught up, so you're good to go for Arduino.
Okay. Dashboard's being a little weird now too. So moving on to Arduino, I'm going to get this relay out of my face here. So Arduino is a little bit more complicated, at least. Well, I shouldn't say that. You have the ability to do a little bit more customization with the Arduino with Cayenne's current implementation of it. Yesterday we added a red LED and also what I call a potato meter, which is just something where you can check the voltage. Today what I'd like to do is I'd like to add a DHT11 sensor. Now I've already wired it up. I've connected it to power, ground, and I have the data pin sending data to the pin 2 on my Arduino Leonardo. So I don't want to go over the wiring because there's lots of tutorials that you can do. If you simply just Google DHT11 Arduino, go to images, or really any sensor, whatever it may be, you'll be able to see wiring diagrams. I think it is worth noting, though, that if you are adding a device that we have in our device library, for instance, we'll do this TMP36, we do give you guys tutorials on how to wire them. There's a link at the bottom that says View Tutorials. And if you click that, that'll take you to diagrams that show you exactly how to wire the specific sensor into the Arduino. So I showed it there. Please peruse it, look at them. They're really helpful. I still use them today. But for today, we're going to add a DHT11. So my Arduino is already online. Now what I need to do is I need to flash new code that includes the DHT11 from my Arduino IDE onto my Arduino device, and then send the data stream that the DHT11 is sending to a widget on my Cayenne dashboard. So we're going to go over that. Now, my assumption is that you already have the Arduino IDE installed, and we'll just go from there. So I'm going to create I already created a, let's see where it is, a sketch file that includes, here we go, that includes the DHT11 code that I used, only to save time and so I could really show you guys what's happening here. So I'll put this a little bit bigger here so we can see. So there's a couple of things that you'll need to actually read data from the DHT11. And one is the library for the specific sensor. Now, I'm going to say DHT11, but you can substitute whatever sensor you're thinking of. Every sensor that you're going to add needs that there needs to have a library to read the data from that sensor that you load onto Arduino. So I went ahead and I Googled DHT11 Arduino library. And usually it's on like a GitHub or something. Adafruit actually has really good libraries. So I went to Adafruit's GitHub to their DHT sensor library. I clicked on download and I downloaded the zip to my computer. And what that download basically contains is, just think of it as files necessary to know how to read data from the sensor that you're trying to add. So once you download the file, then what you do is you go into your Arduino IDE, and again, I mentioned this yesterday, but there's two different Arduino IDEs. There's Arduino.cc IDE and Arduino.org IDE. It doesn't matter which one you use. I happen to be using the .org IDE, but you might be using the .cc IDE, which is totally okay. So once you've downloaded, once you've gone out and found your sensor library, you download to your computer, go on your Arduino, and you're going to go to the Sketch tab. Sketch tab, there it is. And you're going to need to import that library. So you can click Add Library, and then you search for that library in the downloads on your computer. You can see I have a ton of different libraries here. So go and find your DHT library, and then you're going to click Open, and then it's going to get installed or imported onto your Arduino IDE. Then what you'll need to do is you'll need to go and add that library to your sketch file. So you can see I have this. This is my library list on my IDE, and I have something called DHT Sensor Library, and that is a library where I can use to read data from my DHT11. So in the code, I've included this include DHT, and that's basically saying include my DHT library, and that's how we read data from our DHT sensor. Now, another thing is this Ethernet 2 library. This is specific for the Arduino that I'm using. I'm using an Arduino that is using the W5500 chipset. That's a specific type of Ethernet chipset that gives my Arduino internet. Now, it just so happens that you need to download another. You're going to be downloading a few libraries, just a heads up. You need to download another library called the Ethernet 2 library. That's going to help your Arduino give internet connection through that W5500 chipset. And you go about it the same way. You can go ahead and hop on the internet, type in Ethernet 2 library, Arduino, and it pops up. And this Adafruit makes this library again, download it to your computer, and then open it in your Arduino IDE. And then make sure you have this little include Ethernet2.h in your sketch file. And so that's two different libraries we need. I included another library called Simple Timer. And what this allows me to do is to send data to Cayenne at specified intervals. I'll go over that a little bit later. It's not necessary, but it's kind of like good practices. So you don't just constantly send data. You can send data every 5 seconds or 10 seconds to ease the load on your Arduino and the Cayenne servers. But you don't need to worry about that really right now. So one thing that is important to do is to make sure that your sensor is, you tell the Arduino where your sensor is located. And that's what this does right here, the define DHT pin 2. And what that means, what that's saying, is that my DHT is connected to pin 2 on my Arduino. So it's this white line right here, which is connected to pin 2 on my Arduino. So that's the physical pin on my Arduino right here. Next, what we're doing is we are initializing the DHT sensor for the Arduino and creating the DHT pin and DHT type. And what this is saying right here is we're sending a float value, and we're calling it humidity, and this is going to store the humidity value on our DHT11. The DHT11 sends humidity and temperature, so we're actually going to be reading 2 values from a single sensor. And this will store our temperature value. You can see the auth token here. This is important. This basically ties your Arduino to your account and will display your Arduino on your dashboard. And then there's a couple other things. I really, at least for today, I don't want to get super deep into what everything means and how to write everything. I think that's kind of what makes this part fun. Is I'll post this code on the community so that you guys can reference it, and you can sort of learn and teach yourself how to use virtual pins and how to assign variables and how to send data to a variable, send that variable to a virtual pin, and then display that data inside the Cayenne dashboard. Because ultimately, that's kind of why a lot of us are here, are to learn about Arduino and IoT and maybe develop some skills. So I want to provide this to you guys to maybe help teach yourselves some things about Arduino and general coding practices. So what we're doing here is we're sending the humidity value to the hum. And if you remember, we defined hum as a float, and just below it, you can see there's a Cayenne.virtualWrite function. And what we're saying here is we're saying send the hum value right there to virtual pin 1 using the Cayenne.virtualWrite function. And what that's going to do is that's going to send whatever data is coming, the humidity data is going to send through a virtual channel. Now, virtual channel is not a physical channel on the Arduino. Up here, when we defined DHT pin 2, that is a physical channel on the Arduino. But virtual channels, just like they in their name, they're virtual. So it's like a container. It's a virtual container that sends data, and now you're sending that virtual data to Cayenne to be displayed on the dashboard. So just remember that we assigned humidity to virtual pin 1 and temperature to virtual pin 2. The rest of the code here is this basically sends the uptime or the data every 5 seconds, is what I've said. Sending every 1 second is a little overkill. You're just constantly going 5 seconds. It sends, and then it waits 5 seconds, gets a new data feed, sends, and then waits again. And it is helpful to have these serial print code down here, because we'll open a serial monitor and we'll make sure that the data that is actually coming from the Arduino is sending properly to the Cayenne dashboard. So I will make this available to you. I just did a high-level overview of what it is. Now what we need to do is put this code that we just made in our Arduino IDE and flash it onto our Arduino, and then add widgets to the Cayenne dashboard to read the data from our DHT11 sensor. So again, always before you flash code to your Arduino, you just want to make sure that the right board is selected and the right port is selected. So that's good to go. I'm going to grab my auth code that I was given here in my settings.
Hey, Benny, while you're doing that, can I ask you a quick question?
Yeah.
Yeah, just back on the Pi. Just had a quick question. I want to make sure we get to it. Is wanting to know about how to control servos on a Pi.
Yeah.
Do you want to cover that now or later?
Yeah, I'll cover that now. And that's funny. I was thinking about going over that today, but I ended up not doing it just because I really couldn't prepare in time. But so for a servo on the Raspberry Pi, there's specific pins that are set for pulse width modulation, which is how you send commands or send data to the servo to make it move. Now, we have not integrated with the onboard PWM pins on the Pi. It is something that we'd like to do in the future, but there is something else you can do that will work just as well. You can use, I don't have one on me, but there's an extension called a PCA 9865 or 9685, and that extends that PWM functionality to the Pi. And then you can attach a servo to that PWM, the PCA 9685, and that's what you use to control the servo from the Pi. And I might as well show it in the dashboard since it was a specific question. So if you do want to add a servo, what you'll have to do is you have to go to add a new device, go to extensions, click on PWM, and first add your PCA 9685. So you can see it provides 16 channels for PWM output. And you'd attach that to your I2C pins on the Pi, which is really nice. I2C sensors are easy because you just basically attach ground, power, and then those two I2C pins directly to the I2C ports. So once that's connected, then you can attach any amount of servos to that board, to the PCA 9865 board, and control the servo like that. One thing I noticed, though, is I typically had to give external power to that board because the Pi couldn't supply enough power to control multiple servos at a time. Yeah. One more question, just while we're talking Pi and going back between Arduino and Pi. Mike was wondering, I know we're device agnostic, but is there any advantage using a Pi over an Arduino or vice versa in making an IoT project? Yes, and it kind of depends on the use case. You can think of a Raspberry, well, so the Pi and the Arduino really they're two separate, they're kind of in their own categories. The Pi you can think of like a computer. It has an operating system, it has a ton of storage, you can store whatever you want on there, it can make processes very quickly, whereas the Arduino is a microcontroller and it doesn't have a lot of the power that the Pi has. So the Arduino is very good if your use case or your project is just doing something, a task over and over. So you can think of when you flash code from the Arduino from your computer, from the Arduino IDE onto the Arduino. The Arduino is like a workhorse, but it's a dumb workhorse. It just goes over and over. It just runs whatever code that you put on it over and over. It can't really do anything else. So if you want it to sense humidity data like we're doing right now, that's all it does, over and over and over and over. But the Pi is good to be able to run more complex logic and processes that you might be doing for your home automation project. What a lot of users do is use that Pi. Think of it as like the central hub that does all of your computing, but then the Pi controls multiple Arduinos. So you can think of it like that. The Pi is really a good controller, where the Arduino is more of like a workhorse. It knows how to do one thing, and it does it, but it's kind of limited to that. Hopefully that answers your question.
Yeah, that's great. Cool. Thanks. That's it for questions for now. Sorry to interrupt.
Not a problem. So where we left off, we can see that the code that I just did is done uploading, which is a good sign. That means there were no errors and it got flashed on the the Arduino. And furthermore, the Arduino is online, which means that it's properly connecting to the Cayenne dashboard. Now I talked about the serial monitor, which is what we're going to go into right now. And if you remember, this is what we added to the Arduino. And the reason why this is really helpful to add, and just click the serial monitor, is because it will tell us if data is properly coming in, given that we've wired it correctly and we've put the code, which is right here, the serial.print, So more good news for a live demo, that doesn't always go like this, is there's humidity data that's being sent from our Arduino, and there's temperature data. The temperature is in Celsius. I probably could have switched that to Fahrenheit, but I think the US is the only people that use Fahrenheit anyway, so Celsius is probably best for this audience. Okay, so we're getting humidity and we're getting Celsius. I'm going to close the serial monitor, and I'm going to go now to the Cayenne dashboard. So at this point, we need to add widgets to view that humidity data and to view that temperature data. To do that, we're going to add a custom widget. Custom widget is where the power of Cayenne comes in. It allows you to read data from any sensor through the use of virtual pins. I can choose how I would like to view that data. For the first time, I'm just going to choose this value widget. We do give an example, value widget. And now I'm going to enter some information to let Cayenne know just some specifics and how to get the data from the Pi into my Cayenne dashboard. So we'll do humidity first. So DHT, if I could type, humidity, and Arduino Leonardo, that's the right device. And this is important because I/O is the input or output. So we are using not digital, not analog, but virtual pins, virtual input. So I'm going to select virtual. Now, if we were adding like an LED, we would have selected digital. Or for that voltage meter that I showed, we would have selected analog. But we're selecting virtual. And again, virtual is not an actual physical pin on the Pi. We're just saying we want to read data from the container, the virtual pin container that's running on the Arduino. Connectivity is, I forgot which pin we're sending the humidity data to. So I'm going to go back to my code here, and you can see it's virtual pin 1. So for connectivity, I'm going to select V1 data. This is actually pretty important. We do allow you to pick the data type. So if you're using humidity, please select humidity, because the unit that you're going to be seeing the data in is dynamically, you dynamically choose based on the data type. You dynamically choose the widget based on the data type. So if you select temperature, then you'd get Celsius, Fahrenheit, or Kelvin, but if you select humidity, then you get a percentage. So that's why I'm selecting humidity and choosing the right data type. And you can choose an icon. And by the way, we're adding a ton of new data types, everything from like battery percentage, a ton of like 250 different data types. And then at this point, we can add the widget. So I'm going to do that. And there's the widget on the dashboard. And you can see it is now coming in as 40. Now, if you remember when we checked our serial monitor, that was the same value that was coming in from the Arduino. So we know that Cayenne is displaying the same data that is coming off of the Arduino. So that's a very good sign. Sometimes I've had it where I've messed something up and my serial monitor is displaying something, but then Cayenne's displaying another thing. And I forgot exactly what I did, but a quick change, and then I got them working again. So there is the humidity data displaying in Cayenne. Typically what I like to do at this point is I always like to confirm that my sensor is working. So I will put my finger or like try and manipulate the data a little bit just to see if the humidity does change. And you can see it did, so that's a really good sign again. So we know our sensor is working as it should, basically. And you can also confirm on the serial monitor, the humidity went up to 47, and you can see that it's 47 on the Cayenne dashboard as well. But the DHT11 has two data types. It has humidity and temperature. So now we can go ahead and add a widget to view the temperature data. So same process, add a device, custom widget. I can do value, gauge, graph. I'll just do another value. But you could have done a graph or a gauge. I'll label it DHT temperature. virtual connectivity, I think it was V2, virtual pin 2. I'm just going to confirm. So yeah, temperature was sending data to virtual pin 2. Data temperature unit, I think we said Celsius, or was it Fahrenheit? I forget. And we'll pick a thermometer for our icon, and we'll add the widget to our dashboard. And wait for it to appear. Or refresh the page. Sometimes that helps for whatever reason. Yeah, so you can see that, and actually it's in Fahrenheit right now, even though I must have done something in my Arduino code. I just kind of grabbed it and used it for this session. So I could have done something. I think I might be converting it to Fahrenheit or something. I'm not really sure what's happening there, but there's the Celsius data. It's displaying in Fahrenheit on my dashboard. So that's how you use virtual pins. Jake, was there any questions about virtual pins?
No.
Okay. Okay. And that. Go ahead.
I just had one question, but how to interface Cayenne with Node-RED?
I'll have to get back on that one. I'll get back on that question.
Yeah. Yep.
So before ending, I did just want to briefly touch on our community. So we have a lot of users just like you guys who are creating projects, getting help, using Arduino, using new devices like ESP8266, and submitting projects. Like here's a project that was submitted an hour ago. He's turning on a light through, this is actually quite timely. He's using a relay to turn on a light through his mobile phone. So there's his relay connected to that ESP device, and he's turning on a light. So please say hi on the forum. We have a project contest going on right now. If you submit a project, big or small, there is a $200 grand prize, and then also a participation prize. So it's very easy to get the participation prize. Just submit your project to the Projects Made with Cayenne category, the Hackster page, and also Instructables, and you'll get that $50 participation prize. I'll send you a PayPal. So we really want to see your projects. We want to see what you guys are submitting. And we're going to hold more of these sessions in the future. They're probably going to be streamed live on like YouTube Live or Facebook Live, so that way we can interact more with you guys as our audience. You'll be able actually to show like your face and talk, so it'll be a little bit more interactive. And that I think is good for today's question, Jake. At this point, we can open it up to Q&A if there's any questions before you guys go on with your days or nights.
All right, we've done a good job. Thank you, everybody, providing all those questions. It's so great. We're wondering if we're putting these sessions on YouTube after we're done. Yep, we'll put them on our YouTube channel. And I think that we are actually all cut up, Benny, which is great. Benny, by the way, is heading out tomorrow, going to Maker Faire in New York. Oh, yeah. So if you're happen to be there, swing on by. You're in the Arduino booth, right?
Yes. So we are partnered with Arduino, and I'll be displaying actually out of here. So this is what I'm creating right now: a board that has a bunch of Arduinos connected to it, and basically we're displaying this at Maker Faire, and then we're using the Cayenne dashboard, like a big TV right next to it, and controlling these things and showing people at Maker Faire about Cayenne and the Arduino integration. So that's going to be really exciting.
Yeah, great. All right, good. All right, Benny, thanks so much again for today. Thanks for attending. If you have any additional questions that you think of while you're building your product, just come on by the community.
Yes, say hi. And I'll post the DHT, the code that I just used. I'll post it to the community right now too. Okay. Thanks,
all right,
Jake.
Thanks so much. Yeah.
You're welcome. Bye. Bye, everyone. Thanks for coming.